Hey, so I'm making an engine out of cubes. I know that doesn't sound very original, but just stick with me for a second. Look at a game like Minecraft, which is 10 years old already. More than that. But Minecraft's made of cubes, right? Well, actually, it's made of triangles. If you want to be even more pedantic, it was made of pixels. If you want to be even more pedantic, it was made out of an ancient incantation of a language called Java. My game, unfortunately, also has to be made of pixels, but it's going to be made with C++ instead. Which is like if Java took the red pill, escaped the matrix, and became an incel. I'm also using Vulkan because I hate myself. As a heads up for any fellow programmers who operate on the level of API that can get you checked into a cycle word, this video won't be really technical as to how to implement a Vulkan application, but there are a million other engine videos and online tutorials that I've linked in the description, which should give you some help. Most of my project is built off of the basic Hello Triangle Vulkan tutorial from vulkantutorial.com anyways, and an amazing teardown engine breakdown. Also, what my engine does differently from something like Minecraft is, I won't be turning my cubes into triangles. Instead, I'll be turning my triangles into cubes. This will make sense in a minute. I'll be using an algorithm called Raycasting, which if you're on programming YouTube, you've heard before, but I'll explain it again anyways.
All right, 50%. All right, let's do some raycasting math. I'm gonna do all the math in 2D, but it works the same in 3D. So we have this grid of cells which represents our cubes, right? Think like Minecraft, everything exists on a cube basis. So everything exists here on a square basis. What we're trying to find is when a ray that's coming from a camera intersects with one of our cubes. Let's say that there's a cube. Wait for the ambulance to go away. Ignore that. Let's say we want to intersect this section of the grid, or we want to find where this voxel is, or recognize if we even hit it at all. What we have to do is we have to sample points on the line and then check if we're inside of a cube. So, oh, there we are. We're inside of one, right there. This kind of naive approach where we just sample a fixed distance works in a lot of cases, but look at what we've already missed. We clipped the edge of this cube and we clipped the edge of this cube and we haven't checked them. So how do we fix that? Well, we could just sample more. We still miss them. And that also adds more operations, means it's gonna run slower. And for a video game, it's pretty important that it runs fast. So how do we make sure that we sample points on the line, but don't miss a single cube? This is where raycasting comes in. With raycasting, what we do is we find the exact edges of the grid and we sample those points. So sample once here on the vertical lines, and we also sample on all the horizontal lines. So wherever our ray intersects with the grid, we call it a point. And by checking the cells that are hit by those edges, so this edge goes from this cell to that cell. If we check this cell, and then this green one goes from this cell to this cell, so we also check this cell. Red, we check this one. Green, we check this one. And hey, we've hit our target cell. But we can keep going. Check that, check that. In our game, once we hit a cell, we pretty much ignore the rest of them unless it's transparent, because once you've hit something, like, you can't see through it. And the other important thing that we get is the position of the cell that is currently being checked without missing any of them.
So we're done, right? I mean, we can render cubes. What else do we have to do?
A lot.
Well, there is something that I haven't told you, and that's what my computer's been doing while this testing is going on. It looks a little something like... And I want my engine to be able to run on something like this. On this thing. okay, maybe that's a little bit of an extreme example. So how do I plan on eking out that performance? Well, right now what the algorithm does is, for every pixel on the screen, it runs the algorithm for every object in the scene. And this is horrifically inefficient because 90% of the rays that we shoot at any given object don't even hit it. Luckily for us, graphics cards are designed to do pretty much one thing, which is to render triangles and then fill those triangles with pixels. So all we have to do is draw a box around everything. Every single object gets its own box, and then whenever the GPU draws a pixel for that box, we just run the algorithm, and that will draw the object that's contained within that box. This means that for 90% of the pixels that hits nothing, or hits not the object that we're looking at, we don't have to run the algorithm at all. It also means that if a triangle appears behind something we've already drawn, we use a depth buffer to check that. We don't even have to run the algorithm once for it because we can tell it's behind, and we just discard everything. I'm gonna make implementing this sound really easy, but it's not. Yeah, it's really not.
Programmador. I'm a programmer. Fuck.
Oh, there's the...
Fuck.
Oops, all Linux. Alright, there's the code. Done. There's a million and one bugs, but eventually I fixed them, and then here's the final result.
Camera's rolling. I didn't really have a script for this part of the video. I kind of just wanted to talk. I know a lot of you are thinking this, and I've heard this a lot too. This project is pretty stupid. It's borderline pointless and very frivolous and has pretty much zero real world value. I mean, if I wanted to make a game, I could just use an engine. There are like a million: Godot, Unity, Unreal. But that's not really what I'm after here. What I want is a project that will test me until I break, probably. But I find that that's the best way to learn anything. And graphics has always been a kind of passion of mine, and I think that making a game engine is really a test of, not really a test, but a great way to learn more about that field. And you bash your head against that rock, you'll learn so much more than you would if you just kept repeating the same projects over and over again. And it's probably going to take me a long time to make a next video in what I hope is a series of YouTube videos. This one's taken me almost a month, which is way longer than I thought it would take. But yeah, that's kind of how I wanted to end this video, with a sort of a promise for more if you're interested, but more so for myself to make sure that I keep going, because I know it's going to be hard. Thanks for watching.